This is the story of Night Air Flight 816. On the morning of May the 25th, 1995, an Embraer 110 landed at the airport in Leeds from a flight from Aberdeen. Once on the ground, the plane was worked on. Some routine maintenance, nothing too complex. This was all in preparation for the plane's flight back to Aberdeen. The plane was brought to the terminal, and 9 passengers boarded the plane. As they prepped, the pilots kept an eye on the weather. The visibility was at 1,100 meters or 3,600 feet, and the clouds were low at 400 feet. The air was cold and everything was wet. A storm had just passed through the area, but it was still safe to fly. By 4:41 p.m., the engines were started and the plane backtracked down the runway as Flight 816 made its way to runway 14. Once at the runway, ATC cleared them for takeoff. Air traffic control instructed the pilots to take off and to maintain the runway heading of 143. The plane lifted off into the gloomy afternoon, and as it ascended, the clouds swallowed the plane. Just a few minutes into the flight, the controllers could see that Flight 816 was not following their instructions. The plane was in a slight left turn instead of maintaining the runway heading. A radio transmission came through from Flight 816. Nightway 816, we've got a problem with the artificial horizon. We'd like to come back. The artificial horizon is an important piece of equipment. When you're in good weather, you can just look out the window and get a sense for how the plane is oriented in 3D space. You can tell if you're pitching up or pitching down, turning left or right, all by looking at the horizon. But if you're flying at night or in very bad weather, you can't see the horizon. The artificial horizon tells you how your plane is oriented. If you're in instrument conditions without an artificial horizon, you really have no way of telling what your plane is doing. The air traffic controller told the crew to fly due north, but the plane was having a hard time following instructions. It turned left and then right, all while banking sharply. The plane was then handed to the approach controller at Leeds. The controller tells the crew, "I see you carrying out an orbit. Just tell me what I can do to help." The first officer's reply was, "Are we going straight at the moment, sir?" The pilot couldn't tell if they were level or not. The approach controller would have to be their eyes. The controller looked at his radar screen and told the crew that they were in a slight right-hand turn. He then asked the crew to turn left to a heading of 340. At that moment, they were flying in a southeasterly direction, so they needed to make a left turn. Once out of the left turn, they were heading north, and the approach controller verified that they were level. Things seemed to be going their way. The first officer asked the controller if he had any information on the cloud tops. Getting out of the clouds would allow them to navigate visually. The controller immediately starts contacting planes in the area to get an idea about the altitude of the cloud tops. In between this, he glanced at his radar screen just to double check that the plane was in level flight. On one of these checks, he saw that the plane had begun a left turn. It dropped from 3,600 feet to 2,900 feet in about 25 seconds. The left-hand turn tightened as the plane lost altitude, and before long, the plane dropped off of radar. A few residents of Dunsquick Moor looked up to see something falling out of the clouds. Flight 816 crashed just north of Dunsquick. None of the 12 people on board made it. The impact zone showed a plane that had broken up before it had even hit the ground. As it fell, the plane experienced forces so strong that it was ripped to pieces mid-dive. Right off the bat, they were able to eliminate some possibilities as the cause for the accident. The pilots were not incapacitated, the plane had not been struck by lightning, and finally, the weather. The weather was bad, but it was still above the minimums for the area. From ATC transcripts, it was clear that they were having trouble with the artificial horizon. But the plane had 2 artificial horizons, one for the captain and one for the first officer. In most planes, you have a third standby artificial horizon. So if you think one horizon may be malfunctioning, you can just compare the 3 and use the data from the 2 that agree with each other. But the crew of Flight 816 did not have this luxury. This is probably why they asked the controller if they were level. But he was replying based on a few radar returns, so his assessment may not have been perfectly accurate. That brings up the question, what do you do when your artificial horizons fail? Well, there is this technique called the limited panel technique. It gives you a way to level your plane out. First, you need to cancel out the g-forces on your plane. You're going to have to rely on your senses for this. Once you've removed the excess forces on your plane, you can use the turn indicator to bring your aircraft into somewhat of a level configuration. The turn indicator is just a ball in a tube filled with liquid. When the plane turns left, the ball moves to the left. When the plane turns right, the ball moves to the right. It's a very simple instrument. This arrangement is not ideal though, because the turn indicator can be influenced by forces that may be acting on the plane. For example, if you're in heavy turbulence, that ball can move all over the place. But once you have the ball in the center, turn your attention to the altimeter. Maintain a constant altitude and your plane should be somewhat level. The problem with this method is that it really isn't emphasized in a commercial pilot's training. It's more for private pilots who fly smaller planes which only have one artificial horizon. That brings us to the pilots. The investigators believe that the pilots were overcome with a type of spatial disorientation called the Leeds. This is due to fluid in the air being stationary. On top of that, the pilots would be fighting their own psychology. If an artificial horizon failed, it would tell you that you were in a left turn or a right turn, even if you were level. So in level flight, the pilot would have this big artificial horizon telling him that his plane is turning. Even if he knows that the artificial horizon is broken, it's going to take a concentrated conscious effort to disregard that information. This broken artificial horizon could have been so compelling that it could have caused the captain to disregard other instruments like the turn indicator. Conditions like these are perfect for spatial disorientation. After spatial disorientation sets in, the plane could enter a spiral dive, and it would be very hard for the pilots to recover because they wouldn't even know that they were turning. Now, that brings us to the big question. What happened to the artificial horizons themselves? The impact was so severe that they had a hard time gaining any information from them. The artificial horizons were sent to the manufacturer so that they could inspect it. The investigation confirmed what the pilots had told ATC. A teardown showed that the captain's artificial horizon showed that the plane was nose down with a pitch of 23 degrees, whereas the first officers only showed a pitch of -15. That wasn't all. The first officer's artificial horizon showed that the plane was in a right roll in its last few seconds, whereas the captain's artificial horizon showed that the plane was perfectly level. The two artificial horizons kind of agreed on the pitch, but they completely disagreed on the roll of the plane. Since the artificial horizons were damaged so badly, they were not able to nail down the exact cause of the failure, but they hypothesized that a worn-out bearing in the artificial horizon would lead to a loss in roll data. This plane technically had a lot of redundancy. The two artificial horizons were independent of each other. They had different power supplies, etc. But something that could have saved them was a third standby artificial horizon. So the investigators recommended that planes be fitted with a third artificial horizon so that they'd have a triple redundant system. The beauty of this approach is that the pilots would need no additional training to use it. The limited panel technique that we talked about before is expensive because you have to teach it to pilots and then you have to keep training them on it so that they're familiar with the technique. In the end, spatial disorientation can be tough to deal with, even if you have working instruments. In the case of Atlas Air 3591, linked to the video on your screen right now, a small upset caused the pilots to be disoriented, and that had deadly consequences. I guess redundancy and training are two tools that we have at our disposal to make flying a lot safer. Thank you for watching this episode of Mini Air Crash Investigation. If you like the videos that I make, do consider liking and subscribing. It will really help the channel grow. I will catch you guys next time. Stay safe.